So observation number one. Of course, our program begins in main function and it starts to execute. The first statement there essentially refers to the object name cout, which is located inside this standard library namespace named std. So it's kind of fancy name for an object, but this object std : cout represents this console output device, this window with green background and white characters on it, right? So this window is represented by that cout object in our program. And of course, it can basically understand our intents to display things, and we use this a left shift operator as an output operator, and clearly we display something on the string that looks like 1, 2, 3, 4, 5, or 12,345. And that is the variable that we were able to initialize down here in global space. And this is a variable which is an integer variable. We created it in global space, and we initialize it with 12,345. And although this initialization happens to occur at the bottom of this file, regardless of that placement, we include this myheader.h, right? Which basically what it does, what this include does, it essentially looks this up. Oops, let me make sure I display everything. It's too fancy for me. So, this include directive with the name of the file is simply replaced by the content of this header file. However, every pound directive is a signal to the preprocessor of our compiler to say that just check if this name doesn't exist. If it doesn't exist, then make sure that it exists as a symbol during the compilation, and then it finds this end if, and what it does is just basically checks its own syntax, and in its memory, after the file is loaded, this is removed and this is removed, okay, in memory, and then the remaining content extern in dummy is basically replacing these directives. This include directory. So this is what happens when we compile this program. Then of course, similar stuff happens with those includes. Those includes find IOStream and find cstdlib. All the replacements are made, and this also basically gets processed, and something is included at the top of this file, but we don't care because this is not our code, it's someone else's code. But this is pretty much what we're going to get as a result of compiler attempting to compile this program. So essentially, integer dummy is declared. Its value is going to appear elsewhere, wherever the actual declaration of the variable will occur. And you can see that we have this great flexibility that we can place it here or even in some other file. But regardless of that, this program is compiled. And when it's compiled, let me demonstrate that in our drawing. When this program is compiled, so we have this main.cpp, right? This is the file. We have it on disk. It has some text. And the result of this is that we produce an executable file. Perhaps it's called, let me see what it's called. When you go to your project, you can see the debug subdirectory, and right there I have this CIS123 week6.exe. This is the actual executable file, right? So if I go here and start a command prompt, right? So if I go here and basically drag and drop this into the command prompt and hit enter, here it is, right? So that's the program that we just compiled. That's the actual program. Okay, so let me exit this, exit out of this. But in my drawing, I will simply, I don't remember what that name was. I just think about it like main.exe because this is some kind of like executable file that was produced for us, right? So this main exe or whatever its name is, basically is the result of us compiling this program. And the internal structure of this program is such that when it loads into computer memory, right? So when it gets into memory, so the memory, we have a lot of memory, and when our program is loaded into memory, the result of us compiling this program, and so now it gets loaded into memory, and you already know that there's space reserved for the actual code, that is executable code. That executable code includes our main function right here, right? So we have some executable code. It's saved in memory segment called text. Text memory segment contains our code. Then there is a segment of memory where the globals are located. And all initialized globals, like the one we initialize here named dummy, right? We said dummy equals 1, 2, 3, 4, 5. It got obviously saved some here, 1, 2, 3, 4, 5 inside our executable file, already saved on disk. And when it got loaded into memory, magically this value 1, 2, 3, 4, 5 was already in place. And so when main was invoked by the operating system, like our operating system, this Windows 7 system that we have here installed, basically started to execute this main. It found the reference to this global variable, and instantly, regardless of the fact that the actual definition of dummy occurs towards the like someplace at the bottom of main function, regardless of that, dummy was already declared, and by the time the program got loaded to execute, the value was already there in that global memory segment. Okay, so it's pretty powerful. Now let me return back to the way everything was written so that we have proper syntax. Right, I'm just going to restore my edits in order to demonstrate this inclusion of the header file. But this is an interesting aspect of it, is that we decided to have a header file right here, and we just said that we told the compiler, don't worry, when the program is loaded into memory for execution, you will find dummy global variable someplace in computer memory in that global memory segment. And so by the time the statement executes inside main, the value 1, 2, 3, 4, 5 is already you can see it's already in computer memory, and this initialization happens here. Now, we could have done this, of course, right? We could have done this. We could have just declared it at the top. It's not going to change anything because, I mean, the program begins here. This is our main function. It has some executable statements, and the outcome of us just initializing this global variable, that it just gets allocated someplace in memory, in global global memory segment, and it's going to get its value. But it's important that we can declare. So if we wanted to have this in dummy in a separate file, in fact, let's try this. Right? We can go to our project, view, view Solution Explorer. If you're using code blocks at home, of course, there is this manager window that appears, or panel that appears usually on the left-hand side of your screen, right? So I could go here and say add another new item, which will be another new CPP file. By the way, you never add header files to your source files. You only add your CPP files. And so I will name this dummy, dummy.cpp. I don't know what's going to go in that file. That's just the way I'm naming this file. And this way I could just take this, right? Take this out of main CPP file, move it to another side of my window, and use my initialization in a completely different file. Now, since I do have a header which declares this variable, doesn't create it, only declares, lets the compiler know that this variable will be available at runtime, I would normally include this header file in this C++ file as well, right? So now we have the picture has changed somewhat. Let me update this very quickly. So now what we have is basically we have main.cpp, right, which provides the main function with its executable code, and we also provide dummy.cpp, which provides this global variable. In global variable scope, we declare int dummy, right? And we say equals 1, 2, 3, 4, 5. But this executable that we compile, or about to compile, this, I call it main.exe, right? This executable file will contain both main, someplace, main, right? Executable code, and of course the value of dummy 1, 2, 3, 4, 5. And of course this code refers to this value in our program because we're trying to print that, and when it loads into memory, of course, 1, 2, 3, 4, 5 is there instantly because it came from the executable file, and by the time the operating system invokes our main function, it's attempting to access it in memory, and sure enough, it has 1, 2, 3, 4, 5. But the important difference is that our project is now made up of two files, not one file, but two different source files. Okay, so that's the picture that right now I have with respect to this specific program. Oh, and by the way, I saved this file, so I should be able to build it. There shouldn't be any differences in terms of how I run this code, right? So just try running it, and the outcome is exactly the same.